Oxidation-reduction reactions. These are reactions involving a transfer of electrons. So their long name is oxidation-reduction reactions, or we call them redox. That always reminds me of red box. And I think they switched the order because ox-red sounds stupid and redox sounds a little better. I don't know. But redox, oxidation reaction, exactly the same thing. Redox reactions happen all over the place. Iron rusting is a redox reaction. If you bleach your hair, that's a redox reaction. If you make electricity with a battery, which is what's happening in my iPad, you've got a redox reaction. And then many, but not all, of these are going to involve reaction of something with oxygen. So there are other ones that don't involve oxygen, but many of them do involve oxygen. So here's some examples. Here's iron rusting. That's iron reacting with oxygen to form an iron oxide. Here we have combustion. Combustion reactions are redox reactions. So we have methane reacting with oxygen. This is the burning of natural gas. The fundamental definition of what oxidation is the loss of electrons. So if something's oxidized, it loses electrons. Reduction is gain of electrons. And so this can help us to remember oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. So oxidation is loss, reduction is gain of electrons. Oil rig. You have to have oxidation and reduction occurring together. If somebody's gaining electrons, somebody else must be losing them. There's no electron bank where you can just go withdraw electrons. You have to get them from someone. For now, all we need to be able to do is identify, is this an oxidation-reduction reaction? So this is what we're going to learn, is that a substance reacting with elemental oxygen. So you see anything plus O2, redox reaction. If you see a metal reacting with a nonmetal, redox reaction. The more general definition is just one substance transferring electrons to another substance. We will not be able to recognize all of them in this class, but these are the ones we're going to be able to identify. This encompasses more, and if you take Chem 1A, we'll teach you a lot more about that. So let's identify these. Which are redox reactions? How about that first one? What do we have? What kind of an element is this? It's a metal. And what about this one? A nonmetal. So a metal and a nonmetal reacting, we said, was a redox reaction. So this is a redox. And let's just look at this a little more closely. So lithium chloride is an ionic compound, right? It's got two ions. It's got lithium plus and chloride minus. But the lithium started out as an atom. How did it get to be an ion? It lost an electron. What is loss of electrons? Oil rig. Oxidation is loss of electrons. And how did chlorine go from having no charge to a -1 charge? It gained an electron. So here we have a metal and a nonmetal reacting to form an ionic compound. That's always going to be an oxidation-reduction reaction, redox. How about this reaction? Here we've got two metals. What's going on here? Are electrons being transferred? What's happening to the aluminum? How does it become aluminum 3+? Is it changing its number of protons? They can't change the protons. It's going to change the number of electrons. Aluminum, the atom, has 13 protons and 13 electrons. Here, it's a +3 ion. That means it lost 3 electrons to become an ion. The way an atom becomes an ion is by gaining or losing electrons. So here we have an atom becoming an ion, and an ion becoming an atom. Is there a transfer of electrons there? Yes, thank you. Yes, there is. It's a redox reaction. How about this one? Is this a redox reaction? What we're learning is that if you've got a metal and a nonmetal reacting, if you have substance reacting with elemental oxygen, or if you have electrons being transferred, do any of those three things apply to this? I heard a yes. Which one applies? Well, here we have an ionic compound reacting with another ionic compound. And so there are metals and nonmetals involved, but when we say a metal reacting with a nonmetal, we mean a metal element reacting with a nonmetal element. So that doesn't fit. None of them fit for this. This is not a redox. What kind of a reaction is that? Is it a gas evolution reaction? Is there a gas being formed? No. What's this S mean? A solid. What kind of a reaction is this? It's a precipitation reaction. We've got two aqueous solutions. We mix them together and a solid forms. That's a precipitation reaction. How about this? Carbon plus oxygen making carbon dioxide. Here we have a substance reacting with elemental oxygen. This is a redox reaction. Any questions? Combustion reactions are a subcategory of redox reactions. All combustion reactions are redox, but not all redox reactions are combustion reactions. So the combustion reactions are characterized by the reactions of a substance with oxygen to form one or more oxygen-containing compounds, often including water. Combustion reactions are exothermic. That's why we burn natural gas, is to generate heat. If you have compounds that contain carbon and hydrogen, or carbon, hydrogen, and oxygen, the products will always be the same: carbon dioxide and water. So we can predict the products and write a balanced equation because we know that the products of a combustion reaction, if you just got carbon and hydrogen or oxygen, you're going to get CO2 and water. So here we have pentane, C5H12, and combustion. Combustion means reacting with oxygen. So anytime something's burning, it's reacting with oxygen. And the products are going to be the same: CO2 and H2O. So that's something you just have to remember. Combustion, reacting with oxygen, forming CO2 and water. And then we balance this. So let's start with the carbons. We've got 5 here, so we'll put 5 over there. And here we've got 12 hydrogens, and over here we only have 2. And so if I put a 6 in front of that, that'll give me 12 hydrogens. Now oxygens, in this one I've got 5 times 2, I've got 10 oxygens there, and here I've got 6, which is thankfully an even number. So I've got 16 on the right, so I need an 8 over here on the left. And there's my equation. Any questions? Remember, all these videos are on YouTube. If you need to listen again, you can just go on YouTube and hear it all over again.